Okay, hello. We're going to be covering section 1.5 today, which is quadratic equations, solving the quadratic equation. There are three different methods we'll be looking at to solve the quadratic equation. I will cover them separately in three separate videos. So this section will have three videos. So first off, let's talk about what a quadratic equation is. Quadratic equation is any equation that can be expressed as ax squared plus bx plus c equals 0, where a, b, and c are real numbers. That is a quadratic equation. And there are three methods we'll be talking about to solve them. The first method is factoring. Now, factoring can only be used to solve the quadratic equation when you meet certain conditions. And the vast majority of quadratic equations will not be able to solve to use factoring. There's only specific ones. There are infinitely many specific ones, but there are a lot less of those than there are the regular kind. So let's go through the steps of factoring. Step one is to factor out any GCF that you might have, greatest common factor. You factor it out or move it on the side and then continue to work. Step two is to multiply AC together and write this up to the side. Okay. Step three is to find two factors that, when multiplied, add up to equal b. Okay. Now, these factors add up as generic. It could be add or subtract to equal b, depending on your conditions. So if AC is greater than 0, then you're adding to equal b. So you're either adding two positive numbers or adding two negatives, depending on whether b is here. You're adding two positive numbers if b is greater than 0, adding two negative numbers if b is less than 0. So if AC is greater than 0, then you're going to add two positive if b is greater than 0, add two negatives if b is less than 0. If AC, however, is less than 0, then you're going to subtract two numbers to equal b. If b is negative, the larger number is negative. If b is positive, then the larger number is positive. Okay, so step three is kind of involved. Once you do this step and you find these two factors, then you're going to replace, step four is replace b with these numbers. And then step five is factor by grouping. Okay. And step six is solve for x. Okay, these are the 6 steps you need to solve a factoring problem. I guess the easiest way to really go through these is to show you. This is not the only method for factoring. There are variants, different methods. This is just the method that I prefer to to use. If you know another method that you like, as long as it works, then that's okay. So let's look at our first example. So we have 4x squared minus 2x equals 0. Now this is a quadratic. This is the quadratic where c equals 0. So here c is equals 0. It doesn't have a constant term. And this is a good example where the first step is we always factor out a GCF. So when we factor out a GCF first, we're going to factor out 2 and an x. Each term here is a multiple of 2 and has an x. So we factor out 2x. That gives us 2x minus 1 equals 0. So I factored 2x out of both this, and that gave me a 1 here and another 2x there, which is what we have here. Then we can go ahead and, on this one, we can go ahead and skip all the way down to step 6. Now we just solve each of these individually for x. So you have 2x equals 0, and then 2x minus 1 equals 0. Top one here is x equals 0. Bottom one here is x equals 1/2 when you solve them. So here you add 1 to both sides, then divide both sides by 2, and you get 1/2. So that's your first example. That's why we always start with the GCF. Okay, let's move down to the next one. Another example. Example 2. 2x squared plus 7x equals 4. So now we move the 4 over. So it looks like the correct form. Then you multiply your a and your c together. Well, 2 times negative 4 is negative 8. All right, that's our AC. We know that AC is negative, so we know we're subtracting. So I put over here we're subtracting. We're looking for 2 factors that subtract, that multiply to equal negative 8, and when subtracted equal a positive 7 from here. Here's your positive 7, right? So we're looking for 2 numbers that multiply to equal negative 8, then because it's negative, you're subtracting them, they equal 7. Now, since 7 is positive, then the larger of these 2 factors has to be positive. Well, and we could write out all the factors of 8. They're 1 and 8, 2 and 4. Okay. Now, which one of these subtract to 7? Well, 8 minus 1 is 7. 4 minus 2 is 2, so it would be this one. And here we know that the 8 is positive and the 1 is negative. Because 8 times negative 1 is negative 8, and 8 minus 1 is 7. Okay? So that's all that step 2 and 3. Now we need to do step 4, which is replace the b with these factors. So these factors here, they need to become what b is. So we're going to replace b. Watch how we do this. 7 is going to become an 8x and a minus 1x minus 4 equals 0. Okay? So notice that here and here, when we recombine those, we get back to the 7x. These two combine to 7x. So we haven't changed the equation any. Anytime when you can combine it back in, simplify it back down to what you originally have, you haven't changed anything. So by doing this, we're not changing the equation. Now we're going to do factor by grouping. So when you do factor by grouping, what you're going to do is you're going to put a group around the first 2 and a group around the last 2 and put a plus in between them if there's a minus. Because the minus has to go with the number. You can't put it on the outside, so I have to put a plus there. And then we factor out the GCF of the first 2. What can we factor out of 2x squared and an 8x? Well, we can factor out a 2x. All right, that leaves us with an x plus 4. If we were to FOIL this back out, we'd get back to the 2x squared plus 8x. 2x times x is 2x squared. 2x times 4 is 8x. So again, we haven't changed anything. Now we factor something out of this. Well, the only thing we can factor out of this is a negative 1, which we'll go ahead and do. You can always factor 1, and you need to if that's all you can factor. We factor it, it changes the sign. You'll know you've done this right if this and this are the same. Now, we factor out the x plus 4 since it's the same for both. Group what's left. Okay, and we finished factor by grouping. And now we just have to solve by setting each of these factors equal to 0. So finally we solve by setting x plus 4 equal to 0 and 2x minus 1 equals 0. Here you're going to have x equals negative 4. Here you're going to have x equals 1/2. At this point you could check by plugging your numbers back into the original equation and make sure it works out. And it will. I'll leave that as an exercise for you guys. Okay, so there's another example. Let's look at another one. So, what about this guy? Here, we notice we don't have a bx term, which means b is equal to 0. Anytime you have one of these, it only works if there's if these are squares and there's a negative. So this, if it's of this form, it'll only work if this is a square, this is a square, and you have a negative between them. If that's true, then you can factor by grouping. And what you do is you multiply 9 times 25, right? What's 9 times 25? Well, 175, and you try to find two factors of 175 that, when subtracted, equal 0. Or wait, not 175, my bad. No. 10 is 250, 225. Two factors of 225, negative 225 that equals 0. Or you could just remember that if it's of this form, a squared minus b squared, then the factor of it is a minus b times a plus b. And this is an equation that they're expecting you to already have memorized. And we'll go ahead and use this. It's easier than trying to find the two factors. Well, they're going to be 15. 15 times 15 is going to equal 225, and when you subtract them you get 0. So you could do it this way if you want. I'll do it over here. So to replace this with negative 15x plus 15x minus 25, right? And then you're going to factor by grouping. Group here, group here. Here you can factor out a 3 and an x. That'll give you a 3x minus 5. Here you can factor out a plus 5. That'll give you 3x minus 5. These are the same here, so you can group them in front, group what's left, and you end up with that. Or, so it'll work doing this, or you could just use the equation and realize that a is a square root of 9x squared, which is 3x. A is going to be 3x. B is going to be the square root of 25, which is 5. So we just plug this into this equation and get 3x minus 5 times 3x plus 5, which is the exact same answer as over here. So either of these methods will work on this. Okay, so that's when it's in this form here. And these, if you're going to use this method, you have to memorize the equation. Okay, let's do another example. Okay, so we have this guy here, 14x cubed minus 14x squared plus 20x. Notice every term has an x, so, and every term is a multiple of 2, so we can do the GCF trick first. So we're going to factor the GCF of 2x out of everything. That'll leave us to a 7x squared minus 7x plus 10. All right, now we're going to multiply an a and our c. So 7 times 10 is 70. We're looking for two factors of 70 that add, since this is a positive 70, that add equal negative 7. which means since you're adding, oh, I think I wrote this down wrong. And you're never going to add to 7, because let's see, you got 1 and 70, 2 and 35, 5 and 14, and 10 and 7, and all of these add greater than 7. So this is one of those cases where this right here is not factorable. Now let's change it. I'm going to change one thing to make this solvable. Let me see. If I change this to a negative, then we look for subtracting. That makes this subtraction. So we're to subtract a 7. Subtract a 7 might be doable. Nope, it's not. So this is one of those examples where this is not factorable. And you will run into those. So you'll have, all we know is from this 2x equals 0. So one solution is x equals 0. The others could have irrational or imaginary solutions. So this is going to return either an irrational or imaginary. And this is where you run into the weakness of factoring. I could use, in the next two methods, I could have factored this. But using factoring, you can't always. Let's do another one. Let's just do a basic one. What happens if it's something like this? Well, here, you still have a 1 here, so 1 times 6 is 6. You're looking for 2 factors of 6. Since it's add, you're going to add to equal 5. What are they? Well, the 2 factors of 6 that add to 5 are 2 and 3. So we'd replace the 5 with the 2 and the 3x. Then factor by grouping. Here you're going to pull out an x, gets x plus 2. Here you're going to pull out a 3, get x plus 2. They're the same, so you factor out an x plus 2 from both. And you get x plus 3 equals 0. Then set each of the factors equal to 0. And you're going to get x equals -2 and x equals -3. So there's examples of factoring. Normally, in developmental math, you're going to spend like 2 weeks doing this. Here, it's just half of a day, or a third of a day, actually, that they cover this. So they are assuming you already know how to factor, and then just running through a quick review is all they're doing here. If you don't know how to factor, you might look it up at Khan Academy, spelled like that. They have some free stuff that they can teach you with the videos, various techniques for factoring. But this is something that you need to know. All right. Now on